So let's talk about another system of the Earth. Let's talk about the atmosphere. So when we look at our planet, and we mentioned this yesterday, that the outermost layer of our planet consists of gases. That is our atmosphere. So the atmosphere is a thin layer of gases surrounding the Earth. So that's pretty basic definition. We'll get into some of the makeup of it here shortly, but I want you to know what the word atmosphere means. So if you remember, we talked about the origin of the word sphere, the suffix sphere, and we looked at biosphere. Let's look at the makeup of the word atmosphere. It comes from the Greek word atmos, meaning vapor, and sphaira, meaning globe or ball. So it's a literal ball or globe of vapor. So this one is a literal sphere. So let's look at what it's made up. What's our atmosphere made up of? We know oxygen, because that's what we breathe, but oxygen only makes up 21% of our atmosphere. Most of our atmosphere is nitrogen. There's also quite a bit of argon. So these are the three main: nitrogen, oxygen, and argon. So that may come up on a test, so I'd pay attention to that one. Nitrogen, oxygen, and argon. Now, we also have about 0.03% of carbon dioxide, and then everything else, less than a percent, is about, this is all of this here, is less than 1%. These are called trace gases. So trace gases, along with some of the other things, like you see these clouds are made of water vapor, so that are of water droplets. So this is actually a liquid in the air. And then there's also solids in the air. They're in our atmosphere. There's dust, salt from the ocean, pollen, among other things, different pollutants sometimes. And these things, carbon dioxide, the water vapor in the air, even some of the solids will actually help to regulate the temperature on the Earth. So even these trace gases are still important to understand. Now, so let's look at what the atmosphere is made of. So we have here the different layers of the atmosphere. All of it's the atmosphere, but it actually, there's different areas of it, and we're not going to get into a lot of them in depth. I'm just going to cover it today. I think you guys will talk more about that maybe in 7th grade, learn a little bit more, but let's get a little bit of an understanding of some of the different layers of the atmosphere. So it starts all the way down here at the bottom. We'll work our way from the surface up, but the first layer at the bottom is the troposphere. The tropo prefix comes from the Greek word tropos, meaning turn or change, and sphaira, obviously we know that one. So what does that have to do with this first layer? Well, this is the layer where weather occurs. It's the winds are changing, the clouds are moving, the air pressure is getting more intense as it goes down, and this makes up the about 70% of the atmosphere's mass, because all of that above is weighing down. So here's where all of the pressure is. This is the highest pressure in the atmosphere is down by the surface. So change, because the weather changes, the winds change, the air currents move. It's very turbulent. So again, this is like towards the top. That's where commercial airlines fly. This is where weather occurs. Then there is what's called the tropopause. This is the layer between the troposphere and the next layer, which is the stratosphere. Stratosphere comes from the Latin word stratum, which means layer, and we've actually talked about strata or stratum when we talked about geology, and then again sphaira. So it is a globe or a ball that's in layers. Now here, the air is not as turbulent, so you don't see this big mix of air pressure or air currents and things. It kind of just lays flat into layers, hence stratosphere. This is where you're going to see the most important feature, the ozone layer. So the ozone layer is this layer of ozone, which is oxygen, but it is in an interesting molecule, it's actually O3 as opposed to the oxygen we usually breathe, which is O2. So this is O3, and what it does is it filters out certain types of light, and it helps to give us the greenhouse effect. So lets in certain of the sun's rays, blocks others that can be harmful, and helps to regulate the temperature underneath. So the ozone layer is an important feature of the stratosphere. The next layer is the mesosphere, from the word mesos, meaning middle. Now this is important. You're going to see this not only in science, but you're also going to see it in history. You're going to see it um, in music, in languages. Mesos means middle. So this is the middle layer of our atmosphere. And an important feature of the mesosphere, this is where most meteors burn up in our atmosphere. So while they're out in space, remember they're meteoroids, they come into our atmosphere and they're burning, they're meteors, they hit the ground, they're meteorites. So this is where most of them are burning up in our atmosphere. And look at this change in temperature here. So that's one important feature. Another has to do with what they call atmospheric tides. So this is shifting patterns of air currents. You can see the temperature changing there. There's a lot of movement in the air of the mesosphere. The next layer is the thermosphere. Thermo, which you may not know, or you may, thermos means heat. So exothermic reactions, endothermic reactions, you're going to see this word a lot, thermo. So let's keep that one in mind. And this is the warmest layer of our atmosphere. Temperatures here can get as much as over 2,000 degrees Celsius. So what that means, though, is even though you're going to see these extreme temperatures, the air is so thin, the particles are so far apart, that you would actually feel cold if you were in the thermosphere. Even though the temperatures are extremely hot, you would feel cold. Now, one important feature of the thermosphere is this is where we see the aurora borealis or the aurora australis, the aurora, and this has to do with the ionosphere being partly in the thermosphere, but this is where you're going to find that. This is also where the International Space Station is in orbit. Now, we would tend to think of it being out in space, but it's actually still in the atmosphere. Now, it's very high in the atmosphere, but it is in the atmosphere. So this is where it orbits. And then the last part is the exosphere. From exo, meaning outside or outer. You may see this in the word exoskeleton when we talk about insects and certain things like that. And then again, spira. So this is the outer portion of our atmosphere. Now here is where actual portions of the gases in our atmosphere are leaking out into space sometimes. So it's very thin. We would tend to think of this as outer space. Now, it is actually visible in space, though, as what's called the geocorona. So if you see this kind of shaded part, or this like lit up light gray portion here, what you're seeing is actually the exosphere, called the geocorona. And it's actually kind of bigger than what we would think of. So this is taken from space, but here's kind of what it is in comparison with the rest of the Earth. You see it extends out past our magnetic field, and you see kind of even out past the magnetopause, where there's kind of the sun's magnetic and waves and radiation kind of bounce around and move out past the Earth. All of this here is considered to be part of our exosphere, part of that geocorona. So these are the 5 layers of our atmosphere. It would probably be good for you to understand just the basics of them: troposphere, stratosphere, mesosphere, thermosphere, and exosphere.